This is Josh White with JW Math Tutoring. Today's video is going to cover the April 2023 school day SAT exam, specifically Section 3, the no calculator part. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before we get started with the no calculator section from the April 2023 school day test, just a couple things to note. First of all, since I like to show as many methods as possible to solve some of these problems, it is most likely that the time I use to explain these 20 questions will be more than the allotted time, of 25 minutes that you would typically have to complete this test, if you were taking it as an official test. Also, of course, if you like this video, please do click the thumbs up on it and sign up for my channel, by subscribing to it and for notifications as well. Of course, if you have any questions or comments about any of these problems, please do leave them, below the video. All right, so like I said, getting started with Section 3, the no calculator section from the April 2023 school day test. So problem number 1, they just give you a function. It's a quadratic function, specifically a parabola. And they just ask which graph matches this function. So if you are familiar with, transformations or shifts of graphs, you would see that this is basically just the parent function y equals x squared, which goes through the origin or 0, 0, and then it's shifted down 2 units, okay, because we have a minus 2 here, which is outside the parentheses. So the correct answer for this one is going to be letter B. Now, if for whatever reason you didn't remember that or didn't know that, you could also just do the technique, I call point matching, which is pick a value for x, plug it into the equation, like say 0. 0 squared is just 0. 0 minus 2 is negative 2. So you get the point 0 comma negative 2. All right, go through all the graphs. Which one has 0, negative 2? A, nope, it goes through 0, positive 2, wrong. C does not go through 0, negative 2, wrong. D does not go through it either, it's wrong. Okay, so that's just an alternate method you could use if you did not remember about the different types of shifts. All right, question number 2. Here we just have a basic equation with several variables in it. They just want you to rearrange this for C in terms of n and t. So all you have to do here, of course, is divide by n on both sides and just get C equals t over n. So the correct answer for this one is going to be letter D. And I will also point out that an alternate method you could use for this, and this would generally will apply to most kind of like formula questions, where the answers are formulas, expressions with variables, is you could use picking numbers. Okay, you could pick like a value for n and pick a value for c and plug those in and then get the value for t. And then you could go through the 4 answer choices, plugging all 3 of those numbers in and see which one matches or which one is correct. But you shouldn't need to do that in this because, again, it's just one step, divide both sides by n to get your answer. But it is still, like I said, still an option. All right, next question, number 3, they're just asking you to evaluate a function. So, of course, f of 4 just means we're plugging 4 in for x. So once we do that, just have to remember order operations. We're going to do our parentheses first. 4 minus 1 is going to be 3, and 2 times 3 is just going to equal 6. So f of 4 is going to equal 6. Correct answer for this is just letter C. That's it. Moving on to the next page. Question 4, they give you basically an equation of a line here, linear equation, and they want to know which of these matches the graph. So, multiple ways you could do this. You could, first of all, do kind of like point matching, which I talked about in the very first problem. So what that means is, okay, let's let L equal 0, okay? 0 plus n equals 2,000, or in other words, n is going to equal 2,000. So that means for L, which is corresponding to the x, because see, L is on the horizontal axis for each of these answer choices, we're looking for a point that is 0, 2,000, which would be the y-intercept. So we go to A. Does it go through 0, 2,000, which is up here? No, it doesn't. It's wrong. We go to B. Does it go through 0, 2,000? Yes. Keep it for now. We go to C. Does it go through 0, 2,000, which is right here? Nope. It's wrong. D, does it go through that point? No, it is wrong. Okay, so by process of elimination, it has to be, letter B. You could pick a different point as well. You could let n equal 0 and find that L equals 2000, and then you'd be looking for the point 2000 comma 0, which B is the only one that goes through it. Or you could like rearrange this to get the slope of it and find it that way, but I think just finding a point from the function and then seeing which graph goes through that point is probably the quickest and easiest way. All right, in problem number 5, you do have to do a little work with fractions here, which is somewhat difficult. So basically what's going on is he spent 1/6 of his time, okay, doing this designing. He spent a third of the time doing sketching, and then he spent 1/4 of the time chiseling. Now, it tells us here that the total amount of time spent was X hours, okay? This person, Jolin, made a totem pole in X hours. So this 1/6 plus 1/3 plus 1/4, those together are all multiplied by X because they are some fraction of the total overall amount of time, okay? Whatever they, add up to, which we'll get to in a second. Then there's also 24 more hours, come from right here, the remaining 24 hours of the total time for sanding and painting. So you set up an equation like this, where this is the total time, which is X. These are like the fractional amounts of the total time for those 3 activities, and then this is like the 24 additional hours, over here. So what you're going to do is just go ahead now and combine these 3 fractions by get a common denominator. Notice it's going to be 12 because 3, 4, and 6 all divide into 12. So, the first fraction you're going to have to multiply by 2. Second one you're going to have to multiply by 4 over 4. Third one you're going to have to multiply by 3 over 3. So if you get everything over 12, what you're going to get is 2 over 12 plus 4 over 12 plus 3 over 12. 2 plus 4, now we can combine the numerators. 2 plus 4 is 6, 6 plus 3 is 9, so we get 9/12. So that's basically the part inside the parentheses. And then we have the 24 that's added on at the end. And of course, that's still equal to X. Now, if you look at what I have written here, notice it doesn't quite match into the answer choices. That's because 9 over 12 is just reduced to 3 over 4, because there's a common factor of 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. So 3/4 X plus 24 equals X. That's the exact same equation as answer choice D, because you can use the symmetric property from geometry to just flip the sides of any equation and just now write it like this. So correct answer for this one is going to be letter D. A little annoying with having to work out, all the fractions and the common denominators, but it's not that difficult because, the denominator is only 12. It's not that large of a number. Okay, here we have question number 6 with with a radical that is being transformed or changed into a rational exponent. So hopefully you know the rules of radicals, and that basically says if you want to rewrite it from radical form to rational exponent form, the index, which is the type of radical, which in this case is 4, it's a 4th root, goes in the denominator of your fractional exponent, and the power that the variable or number is being raised to, which in this case is 9, it goes in the numerator. So this is just a to the 9/4. Correct answer is going to be letter A. That's it. We're just going from a radical to a rational exponent. Number 7, we have a circle, and we have some information about it, just its center and its radius. So hopefully you know the standard form equation for a circle, x minus h squared plus y minus k squared equals r squared, where h and k is the center. So in this problem, h is 3, and k is going to be 5. So just replace h with 3 and k with 5. And r is 6. So that means on the right we technically have 6 squared. Of course, we would simplify that out to 36. So now when we look at what the equation looks like, we can see that it's going to be answer choice C right here. X minus 3 quantity squared plus y minus 5 quantity squared equals 36. Moving on to number 8 below it. Here we have one linear equation, in two variables, x and y. And there's a second linear equation of which the answer choices makes up the second equation in this solution, in this system. And so they want to know which of these answer choices is it such that this system of linear equations only has one solution, meaning if you graph the lines out, they only intersect once. So there's multiple ways you could look at this. You could either A, look for the different slopes, because if two lines have different slopes, then they will automatically intersect once. So if you, and now this, here there's multiple ways you could do it. And I'll also show a second method to do this as well. So first method, like I said, okay, look for different slopes. So the slope of this first one, if you are familiar with standard form and the shortcut negative a over b, then you could just look at this and you could say that the slope is going to be negative 3 over 4. However, if you don't remember that, you could rearrange it and you could get, you could put it into slope-intercept form. And notice I get the same answer, okay? So for the first line, the slope is negative 3/4 right here for m. So now what you have to do is you have to go through each of these answer choices and see, okay, which one does not have a slope of negative 3/4. So for the first one, if you rearrange it, you're going to get negative 3/2 x plus 4 equals 2y. And then when you divide by 2, you get negative 3/2 divided by 2, and that technically becomes negative 3/4. You can do the fraction division sideways if you're not sure or not confident of that, but this one has the same slope. Therefore, it will not have one solution. It will either technically be no solution if the lines are parallel, or it would be infinite solutions if it's actually the same equation as the original one. So we get rid of that. Okay, the second one, you subtract 3x and you get 4y equals negative 3x plus 4. Then you divide by 4. Okay, I get a slope of negative 3/4. That matches, therefore it is not the answer. For C, I subtract, let's see here, negative 4x. So I get 3y equals negative 4x plus 8, divide by 3, divide by 3. Notice this is negative 4/3, not the same as negative 3/4, even though it's the same numbers and it looks similar. So this one should be the correct answer, letter C. And then for D, it's going to be 8y equals negative 6x plus 16. So we get y equals negative 3/4 x plus 2. Notice in D, it's actually the same exact equation when we put it in slope-intercept form, so that would technically be infinite solutions if it was D. But since the slope is the same, that means they will not intersect one time. There will not be one solution. Cross it out. Okay, so C is the correct answer. Now, so that's one way to check, and we're looking for different slopes between the given line right here and whichever one is our correct answer. Now, just to clear out some room, an alternate way that we could do this, so that you can look at these types of problems, and this is usually helpful for when they're in standard form, is you can look for basically different multipliers on the x and y terms. So what I mean by that is, here we have 3x plus 4y equals 8, okay? For the solution, for the system to only have one solution, i.e. to intersect once, what's going to be true is that the multipliers, say from the x term to the x term and the y term to the y term, will be different. If the multipliers are the same, then it's either no solution or one solution. Basically, it depends on what the multiplier for the number term is. So what I mean by that is, let's look at this first example as going from the small to the big. So in other words, if you have 3/2, you would multiply by 2 to turn that into 3. Similarly, if you had 2y, you would multiply by 2 to turn that into 4. So for A, x and y have the same multiplier. Therefore, it is not the correct answer because we are looking for, again here, just like we were looking for different slopes previously, we're looking for a different multiplier on the x and y terms. For b, notice it's 1, 3x times, 1 is 3x, so times 1. And for the y's, it's also times 1, 4y times 4y. Since they're the same number, positive 1, eliminate it. Notice for c, they're going to be fractions. It's for technically for c, for 4x to 3x, you know, 4x times what is equal to 3x? It's going to be a fraction. It's going to be 3/4 to cancel it out. You don't need to know that. All you need to recognize is that in C, it's not going to be the same number. 4x times something makes 3. It's going to be a number less than 1, whereas 3 to 4 on the y terms is a number greater than 1. It's technically going to be 4/3. So the multipliers are different. Therefore, C is going to be the correct solution. And then D, you could also look at it and you could recognize that, like going the other way, 3 times 2 equals 6, and 4 times 2 equals 8. Same multiplier in x and y, therefore it's either no solution or infinite solutions. So again, correct answer is letter C. There's multiple ways you could figure this out, and I just demonstrated 2 of them. Now, problem number 9 back at the top of the page. This is just a basic quadratic equation. You can solve it by completing the square. You can solve it by quadratic formula. I would probably do quadratic formula only because the b term here is odd. If the b term is even, completing square is probably easier, but if you try to do completing square, you're going to get fractions, and it's just going to be probably easier to do to plug into quadratic formula. So we've got negative b, which is negative 3, plus or minus square root of b, again, negative 3 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times 1. So we've got positive 3 plus or minus over 2. Notice right away off the bat, a and b are out because they have a negative 3 in front. So now really all that matters is what's the number under the radical. That's basically what distinguishes C versus D. So negative 3 squared is 9. Negative 4 times 1, negative 4 times negative 1 flips it to positive 4. So it's just going to be equal to 13. So correct answer here is going to be D. Notice they technically say what is one of the solutions. That's why they only have the positive here. They just chose that one instead of the negative. Now moving down to problem number 10 at the bottom of the page. So here we have a function, and we're told that it represents the perimeter of a rectangle. So hopefully you are familiar with the formula for perimeter of rectangle, 2L plus 2W. However, in this case, because x corresponds to the width of the rectangle, they tell us that right here in the problem, technically the width is going to be first in this formula, so really it's going to be 2W plus 2L. And then if you match up the function, you can just see that when you basically, like I said, compare the individual parts, the width is equal to x. They tell us that. So, the 2 matches up. The width corresponds to x. This 2 matches up. So what's left for the 2x plus 1? Well, it has to just be equal to the length of the rectangle. So that's it. Correct answer to this question is A, and there's no more work, nothing else that needs to be done on it. Top of the next page, here we have a problem where you have a slope of a line and you have an intercept, but the intercept has a variable in it, not a numerical value. And they want to know what the y-intercept of this line is, again, in terms of that variable, not a numerical value. So there's 2 ways you could do this. So if you just went ahead and used the given information, meaning the variable point, you could just plug everything into y equals mx plus b and just solve for b, because they want to know the y-coordinate of the y-intercept, which is what b is. So for y, I'm going to plug in my y-coordinate from the x-intercept. My slope is negative 4/5. My x coordinate is r over 2, and then plus b. So you just go ahead and multiply this out. You get negative 4r over 10. Now notice you could also technically reduce this because 2 goes into 4 2 times. So we could actually reduce it to 2/5 right away. So we get negative 2r over 5 plus b. Then you just add that to both sides, and b comes out to be 2r over 5. So the correct answer is going to be letter B. Now, if you didn't recognize that or weren't comfortable working with a an x value, an x coordinate value that has a variable in it as compared to just a number, you could also do this by picking numbers. So what I mean by that is I let r equal 10. Therefore, my x-intercept, which is going to be 10 over 2 comma 0, or basically it's really just 5 comma 0, when you do 10 divided by 2. And now I'm going to go through the same process, but now it's all going to be numbers. So it's still going to be 0. It's still going to be negative 4/5. It's going to be 5, and then plus b. So we get 0 equals, now it's negative 4 because the 5's cancel out, plus b. So b equals 4. That means we have to go through the answer choices, plug in 10 for r, and we're looking for the one that simplifies to positive 4. That's going to be the correct answer. So A and C are out right away because since r is a positive number, when you plug it in, the overall result will be negative. So just cancel those out. So now you're down to B versus D. For B, it's going to be 2 times 10, which is 20 over 5. That does equal 4. For D, it's going to be 5 times 10, which is 50 over 8. That clearly does not equal 4. So correct answer is going to be letter B, as well. All right, for number 12, here you have a sphere and a cylinder. And you're given the height of the cylinder. They both have the same radius, and we're asked to find what the value of that radius must be in order for the volume of sphere, so volume of sphere, to be twice, i.e. 2 times, volume of cylinder. So hopefully you know the formulas for these. If not, they are provided on the test. But basically, you're going to have the volume of the sphere, which is 4/3 pi r cubed. And then that's equal to 2 times the volume of the cylinder, which is just pi r squared h. Now for h, I'm going to plug in the height, which is given as 18. And then I'm going to multiply 2 and 18 and get 36. Also, notice what I can do is I can cancel out the pi's because you could just divide both sides by pi. Like you could just do this, and they would cancel out on both sides. And here's one more thing we can do for simplification. We can divide both sides by r squared, even though it's a variable. On the right side, that is going to just completely eliminate it, and all we have left is 36. On the left side, we've got 4/3 r. One thing to mention, the reason we can divide by a variable or r squared here is because we know it is not 0. Like normally when you're solving an equation, you would not divide by a variable to cancel it out because there's a chance it could be 0 and you can't divide by 0. But here, look at the answer choices. We know it's not 0, so that's why it's allowable. So at this point, basically, you could just multiply by 3/4 in order to get r, the radius, by itself. And here I would notice 4 goes into 36 9 times, and 9 times 3 is 27. So the correct answer for this is going to be letter C, 27. Couple things to mention. First of all, you could also do 36 times 3 and get 108 and then divide that by 4, but I think it's easier to do it the way I did it because the numbers remain smaller. Second, you could technically have done this using back solving, like once you set it up, but it's kind of a pain because like A and B have decimals in them, and because there's no calculator, you'd have to do it out by hand. But it is still possible that I guess you could like plug the values in for the radius and see which one gives you the same numerical value on both sides. All right, now question number 13. Here we have an absolute value equation. So the first thing I'm going to do here is divide by -2. And then after that, we can now set up the two different equations that we're going to solve. So the first one looks like the original problem, just no absolute value signs. The second one is going to have the left side, same as the original problem, no absolute value signs, but on the right side we put a negative in front of the 2x. Now when you solve each of these, on the left you subtract x, and you're going to get x equals -5. That's it. On the right, I would add 2x, and then I would also add 5. So I would get 3x equals 5, or x is going to equal 5/3. So I now have two answers, but we do need to double check, make sure both of these answers, or at least one of these answers, works. The reason is because we have a variable on the right side. If we had an absolute value equation and it was equal to just a number, then typically you don't have to check the answers by plugging them back in. But because we have a variable, we do need to check our answers. So I'm going to check negative 5 first because that's easier to work with than the fraction since this is no calculator. So I'm going to go to the original problem. I'm going to plug in negative 5 for x. So we do that on both sides. And we're going to get negative 2, okay, negative 10. On the right side, notice you get positive 20. However, on the left side, the absolute value of negative 10 is going to be positive 10. And then when you multiply that by the negative 2 out front, you are going to get negative 20. Notice that negative 20 does not equal positive 20. That statement is never true. That means that negative 5 is not an answer or not a solution to this problem. Therefore, the correct answer is going to be B, 5/3 only. Now, one other thing just to be aware of, you could also have solved this problem by back solving. Basically, what you have to do is probably start with negative 5, plug that in like we just did here, see that it doesn't work. That would eliminate A, and that would eliminate C. Then, when you get down to B or D, I would probably pick 5 and plug that in, because that's much easier to work with than 5/3. When you plug in 5, you'll see that the left side is just 5 minus 5, which is 0, and that doesn't equal, the negative 20 you get on the right side. And then you could eliminate D, and you'd be left with B, just by process of elimination. So back solving would work for that problem as well. Moving back up to the top of the page, question 14 is a very short basic problem because they're just asking for the y-intercept here, and we know the y-intercept happens where the x value is equal to 0. So we just take 0, we plug that in for x, and then we evaluate this function. 3/4 to the 0 is just 1. We add 5 to that, we get 6. Therefore, the y-intercept is just going to be 0, 6. Correct answer is letter D. No more work is needed for that. Notice that A and B you can automatically rule out because their x-coordinate is not 0. So, you're down to C and D like without even doing any work whatsoever in the problem. All right, for 15, now this problem, there are multiple ways you could solve it. I am going to show both ways. I mean, they're somewhat similar. So first, uh, I'll go through the method you would use if you just kept it in this form, which is a modified version of the intercept form. So intercept form normally for a quadratic equation is like x plus x minus p times x minus q, whereas this has 2x plus a number, 2x minus a number, but it's close enough. And so the minimum value of any parabola specifically one that opens up is going to have a minimum, all right? So just hypothetically, say it looked like this. The minimum value always occurs at the vertex. And specifically, the minimum value is the y-coordinate of the vertex. In other words, it's equal to the k value from h comma k. So that's what we need to find ultimately to get the answer to this problem. The way I'm going to do that is first I'm going to find the two zeros or x-intercepts, and I'm just going to set basically each factor equal to 0 and solve it. So the first one is going to basically give me negative 3/2 or negative 1.5. The second one is going to give me 5/2 or 2.5. So the property that you need to know for quadratic functions is that the vertex, its x-coordinate, is symmetric with respect to the x-intercepts. So what that means is the two zeros, the two x-intercepts, are the same distance away from the vertex, both left and right. In other words, another way to say that is, if I average my two x-intercepts, or my two roots, zeros, whatever you want to call them, that will give me the h-coordinate, the h value, x-coordinate of the vertex. So I take negative 3/2, I take 5/2, I add those together, and then of course to average them, two numbers, you divide by 2. So when I add them on top, I get 2/2, and that's just equal to 1. So the h value of this vertex is equal to 1/2. Now we take 1/2, we plug it in for x to get its corresponding y value, or the k, and that will be the answer to the problem. So if you do that, it's actually not going to be too bad because of the 2's, which will cancel out the fractions. So as I'm plugging it in here, notice again the 2 times the 1/2 is just going to simplify to 1. So you basically get 1 plus 3 times 1 minus 5, or in other words, we get 4 times negative 4. That equals negative 16. Correct answer is letter A. So in other words, this vertex happens at 1/2 comma negative 16. Now, let's say you didn't know that or you forgot that property about the x-intercepts being symmetrical on either side of the vertex. Instead, what you might do is find the h value using this method. So what you would want to do is FOIL out these parentheses to put the equation or the function into standard form or quadratic form. If you do that using FOIL, first outer inner last, you're going to end up with 4x squared minus 4x minus 15. Then you can use the shortcut formula, which is that the h value is equal to negative b over 2a. So that would be the opposite of negative 4 over 2 times 4. Okay, that just becomes positive 4 over 8, which is equal to 1/2. Then once you have that, again, you have to plug that back into the function to get the k value for the actual minimum. And here, I would plug it into the intercept form, the original version you're given. You don't have to plug it into the quadratic or standard form. It's just going to be a pain dealing with the fractions because like you have 1/2 squared. It's going to be much quicker and easier, you can see, just doing the same thing that I did, right down here. But you're going to get the same answer of negative 16. All right, moving on to the grid-ins, the student-produced response problems. So for the first one here, number 16, I would go ahead and I would multiply on both sides by an 8 to clear out all the fractions. So this 8 cancels out with this 8, and we have just x. This 4 cancels out with this 8, and we have a 2, and 2 times 1 is 2. And 2 goes into 8 4 times, and 1 times 4 is just 4. So x is just going to equal 2, and you just grid into, that's it, nothing more to do to that problem. Below that, problem number 17. So here you have an expression, and basically they give you the simplified form of it, 1/3 x to the b. And they want to know what b is. So notice that 4 over 12 just reduces to 1/3 because 4 goes into 12 3 times. And so the x to the b is just what you get when you use the rules of exponents for the x to the 11th or x to the 5th, which is subtraction. 11 minus 5 equals 6. So this is going to be x to the 6th. In other words, b equals 6. And so this 6 is the number that you grid in. Nothing more for that problem. Now for 18, there are multiple ways that you could reason this one. So one way to reason this is that when you have a right triangle, and you have the two acute angles in the right triangle, i.e. the two non-right angles. Basically, there's a property in math that the sine of one angle will equal the cosine of the other angle. Okay, and that's going to be true for both angles. So in other words, the sine of A is equal to the cosine of B, or the sine of B is equal to the cosine of A. So that means in this problem, well, if sine A is 0.7, that means cosine B is also 0.7. So correct answer is just either 0.7, or you could also grid it in technically as 7 divided by 10 if you want to put it in fraction form. Now, if you don't know that property or don't know why that happens, then you could also reason your way through it like this. So we have a triangle here. C is the right angle. Let's put B down here. Let's put A up here. Okay, we know sine of A is 0.7, so I'm going to say that this is 7 and this is 10, but if you wanted to make it 0.7 and 1, like that's fine. You could just as easily do that as well, okay? Because we know sine is opposite over hypotenuse. So now when I go to do the cosine of B, okay, cosine of B is going to be the adjacent, which is 7, or if you use 0.7, that's fine. I go set up the trig ratio, cosine of B, adjacent over hypotenuse. So it's just going to be 7 over 10. So that's just another way you could think through this if you didn't know that property about, the two non-acute angles in a right triangle. So just, again, 0.7 or 7 over 10, that's what you, one of those two is what you would grid in. Now for number 19, here you have a function. This looks like it is a fairly difficult advanced problem, but it's actually not that difficult to work out. It's a little tricky to the reasoning behind it, but in terms of the actual work, it's not bad at all. So here you have this function, and then it says, okay, when you plug in some h minus 5 you get 0 as an output for this function. Like, what does h have to be here? So here's the way to think about this. If you set this function equal to 0, okay, notice it's already factored, so you can just set each factor equal to 0, and you can solve for the, basically for the roots, the solutions, the x-intercepts, whatever you want to call them, the zeros, it's all different terminology to just say the same thing. So for one answer, you get r equals 1. For the other one, I mean, technically there's two of them, so you could square root it, or you could just write it out twice, but this one's just going to give you technically r equals -2. Okay, so when you plug in -1 for r in this function, or you plug in -2, +1, excuse me, +1 or -2 for r, you're going to get 0 as your output. That means that h minus 5 has to equal +1 or -2. Okay, because it tells you when you plug in h minus 5, you get 0 as your output. So h minus 5 has to equal 1, or h minus 5 has to equal -2. If you solve each of those, just add 5, you'll get h equals 6. Or for the second one, if you add 5, you will get +3. So there's two possible answers you could put for this one, either +6 or +3. Now for problem number 20, the last one here, this is a system of linear equations, and this I'm going to solve using elimination. So first thing I'm going to do is I'm going to add the 8x here to move it over to the right, and then I'm going to get 8x plus 10y equals -24. Just one thing to note, after I added the 8x over, I technically flipped the sides of the equation. That is allowable because of the symmetric property in math, which says if a equals b, then b equals a. You can just flip the left and right of an equation. And on the bottom, I'm going to add the 18x over to the left. And then, let's see, plus 15y equals 6. Okay. We're solving for x here. That's what the problem asked for. So that means what I want to do is I want to cancel out y. Because if I cancel out y, then I'll be left with x, and then I can get x, and then that's it. I don't have to do any more work. Otherwise, if I chose to cancel out x, then I would get y, and then I'd have to do more work of plugging y back in, to get x. So the least amount of work is going to be canceling out y. All right, so I'm going to make the y coefficients into opposite values. I'm going to multiply the top by -3 and the bottom by +2 on both sides. And that's going to give me -24x plus 30y, minus 30y, because I'm multiplying by -3, plus 72. Again, this is the process of elimination that I am going through right now. The bottom, 36x plus 30y equals 12. Now we can add down the columns. The y's cancel out, which is what we wanted. I'm left with 12x. It's positive. 72 plus 12 is 84. Divide both sides by 12, and x equals 7. So that's what you will grid in. That is the answer to this question. So that was the no calculator section from the April 2023 school day exam, basically section 3. If you have any questions on the problems on this section, please do leave a comment below. Otherwise, click the thumbs up on this video if you liked it and my other math videos. Subscribe to my channel, sign up for notifications as well. And be on the lookout for more ACT and SAT math-related content coming up soon.